Hi, in this tutorial we are going to solve a question related to energy diagrams for chemical reactions. The question asks, if a reaction has the following energy diagram, label the parts of diagram corresponding to the transition states, activation energy, delta G double dagger, and delta G superscript 0, which is Gibbs free energy change for each step and overall reaction. State each step and overall reaction as endargonic or exergonic. So, in order to solve this question, we have to label the parts of this energy diagram as reactants, transition states, products, and then by getting difference between either reactants with products or between transition state and reactants, we can label activation energy or Gibbs free energy change. Okay, let's start. So let's write on the diagram what we have. So basically this energy diagram belongs to a two-step reaction. So why we have a two-step reaction here? Because we have here one step with a transition state and the second step with another transition state. So definitely we have two steps. And let's start writing the necessary parts for this question. So we can say that this point belongs to reactants, initial reactants, and then this point, the highest energy point along this energy curve, belongs to transition state, and let's say this is the transition state 1 for the first step. Then this part is products. Let's say that this is P1 because this part belongs to the products for the first step, for the initial step. Let's write a bit better, P1. Okay, then what's going to happen? The products of the first reaction will behave as the reactants of the second reaction or second step. So let's say that P1 will be equal to R or reactants 2. Let's say this reactance is equal to R1, and then this point is going to belong to transition state 2, and then this final point will belong to products of the second step. Okay, after labeling reactants of the first step, transition state of the first step, product of the first step, and reactants of the second step, which they are the same, then the second step's transition state and the second step product. Okay, now after labeling transition states, let's start labeling the necessary parts for activation energy. We know that the activation energy for each step is equal to the energy difference between the transition state and the reactant. So let's just label this difference between transition state and the energy of reactants as delta G double dagger 1, because we have two steps. So this is the activation energy of the first step. Then for the second step, again we can draw a line here with dashes, and here same. Let's try to be a little bit better. So this difference between the reactants of the second step and the transition state of the second step is going to be equal to activation energy for second step, and then we have to label Gibbs free energy change for each step. So for the first step, let's look at the energy difference between products and reactants are equal to Gibbs free energy change. So we have to label from here to here as delta G first step 0, the standard states. And for the second step, let's move this line all the way here, and let's move this line all the way here. So this part belongs to energy difference between the reactants of the second step and the products of the second step. So this has to be delta G to 0. So we identified or we just wrote the energy change, Gibbs free energy change for the second step. And then the question also asks you label overall reaction for overall reaction. So let's start from the initial reactants, and let's go all the way to the end. So the energy difference between the initial reactants and the final products is called the Gibbs free energy change for overall reaction. Okay, and one more point maybe we can show. Sometimes you are asked what is the activation energy for the overall reaction. This is basically the activation energy for the overall reaction, which starts from the energy of initial reactants and the highest transition state point. So basically we have two transition states, so the overall activation energy will be equal to the energy difference between the highest energy transition state and the initial reactant. So this point we can call activation energy for overall reaction. Then the question also asks us state for each step and overall reaction whether they are endorganic or exergonic. Let's look at for the first step what is the energy difference. Let's write here delta G1 is greater than 0. If you look at here, the energy difference for the first step greater than 0, we have to say that the first step is endergonic. And for the second step, let's look at the second step. Delta G is here, so we have to look at whether it's positive or negative. So let's write here delta G2 is less than 0. It's negative because it is equal to energy difference between the products of the second step and the reactants of the second step. It's clearly negative, and we have to say that the second step is exergonic. And overall reaction, let's look at the sign of overall Gibbs free energy change of overall reaction, and let's write delta G overall is greater than 0. If you look at here, this is the delta G overall, delta G value for the overall reaction. It's clearly a positive value, has a positive value. So the overall reaction is endergonic. Thank you for watching.